Wowzers! Hi, in this video I'm going to show you how to use integration by parts, but for a little trickier problems. Here's our first particular issue here, and I'll write the general rule for parts. The antiderivative of u dv equals uv minus the antiderivative of v du. So I have to make that fit this particular model. So as we have in the past, I'm going to let my u be x squared, which therefore means du, the differential u, will be 2x dx. Which means that everything that's left has to be dv. So my dv is cosine x dx. And to get from dv to v, we're going to anti-differentiate. So the antiderivative of cosine is sine x. Okay, so once my u's and v's are established, that ends up being u times v, so it's x squared sine x minus the indefinite integral of v, which is sine x times du. So that ends up being 2x sine x dx. Right? My v is sine x, and my du is 2x sine x. Okay. Now look what happened. I bumped the power from the x squared down to a 2x. Okay, now I still have a problem because of this extra x in here in the product, and substitution is still not appropriate, nor can I immediately integrate 2x times sine x. There's no product rule for integration. So what I have to do is one more time apply integration by parts, but now integration by parts is applied to 2x sine x. So the x squared sine x comes down, minus, and now for this round, oops, my u is going to be 2x, and so I'm running out of room here. So my u is going to be this yellow 2x, therefore my du is going to be 2 times dx, which means that my dv for round 2 is going to be everything that's left over. And the antiderivative of sine, if dv is sine, then v, the antiderivative, is negative cosine x. Okay, so I have my u's and v's and du's and everything I need in dv, so now I just plug and chug. And again, I'm kind of thinking about this piece right here. So that by parts rule is equal to u, which is 2x, times v, which is negative cosine x, minus the indefinite integral of v du. And v is negative cosine x, and du is 2 dx. So I'm just going to rewrite it like that. Okay, so now I have some distributing to do. Well, the first thing I'm going to do is take this negative sign out, and that's going to multiply by the other negative sign in front to make it plus. And so I'll just pull everything down now just to work it out a little bit. X squared sine x minus negative, so that's going to make it plus 2x cosine x. I just pulled that down. And then we're going to subtract, this negative sign is distributing here, the antiderivative of 2 cosine x, which now I'm at a point where I can integrate that guy. Okay, so what happened was my original x squared right here bumped to a 2x, which then bumped to a 2. Okay, and that's what parts does for us. Integration by parts. It bumps the power down each time until eventually there's no x, or in this case polynomial term. Right, so now I can integrate 2 cosine x. The antiderivative of 2 cosine x is 2 sine x, plus my constant of integration. Okay, so there are two parts there. Okay, the first round of integration by parts bumps the x squared down to a 2x. The second round, when I apply parts then again to this piece, bumps that 2x down to a 2, which I can then integrate. Okay, so that's kind of a trickier type of integration by parts. Here's another type of integration by parts where we have kind of parts combined with substitution. So here's the general rule for parts again. uv minus the antiderivative v du. That's a minus there. And so here, as I always would do, or at least for the problems we've done, I'm going to let my x be u, and everything that's left over is going to be dv. So you have to make it fit that mode. So I'm going to claim u is x, therefore du is 1 dx, and my dv is going to be the yellow piece, cosine of 4x. And so if I know dv and I need to get v, I integrate, find the antiderivative of cosine 4x. So, how do we find the antiderivative of cosine 4x? So we're kind of doing this, so if there were a little asterisk, to get from a dv to a v, you integrate. So what I'm doing here is I'm trying to find v, which would be the antiderivative of cosine of 4x dx. Okay, so it's a little substitution problem within a parts problem. So of course to solve this I need to let u be 4x. Again, this is a different u, a lot of u's hanging around here. But to evaluate the antiderivative, if I know dv is cosine 4x, I need v, I have to use substitution. So therefore du is 4dx. So that ends up being, by substitution, a fourth of cosine u, which ends up being, by rule, a fourth of the sine of, which is u, 4x. And I don't really need my plus c, so I'm going to take that 1/4 sine of 4x, which is the antiderivative of cosine of 4x. Okay, now I'm ready to plug and chug. So now back to the original problem, part of which was using substitution to integrate my dv term. And let me make that look more like a v. Using v's, it gets so confusing. So now I'm just going to plug and chug. uv is x times 1/4 sine of 4x. I'm going to call that x over 4 sine of x over 4. 4x rather. So there's my x, my uv. Let me clean it up a little bit. Minus the antiderivative of v, which is a fourth of sine x, du, and du is just dx. So here comes this puppy, 1/4 sine of 4x. And my du is just dx. Okay. So now I'm at a point where I can just integrate this little piece right here. And hey, guess what? To integrate that, again, I need to use substitution. So I'm mixing techniques here. Minus the antiderivative, well, this is kind of another u here. Again, to find the antiderivative of 1/4 sine of 4x, I let u be 4x. Therefore, du is 4dx. So this 1/4 comes down by the coefficient rule times. Actually, let me not combine steps just to make it easier. That ends up being 1/4 sine of u, u being 4x, okay, times another 1/4 du. So it ends up being 1/16 sine u du. And now we integrate that. 1/16 sine u, the antiderivative is negative 1/16 cosine of u, which is 4x. Okay. Now I bring everything else down. Bada bing, bada boom. I get x over 4 times sine of 4x. Minus minus turns out into plus 1/16 cosine of 4x plus my constant of integration. Okay, so both of these are a little trickier parts problems. Here I have parts twice, so I have to do it times 2 really. One iteration here, second iteration here. And this one's just a little tricky because you got substitution involved too. Actually, two substitutions. One to find the antiderivative of cosine 4x to get from dv to v. Oops. And then once again to find the indefinite integral of a fourth of sine of 4x. Okay, so you have a lot of u's, a lot of separate u's flying around here. But stay organized and you can do it. Pun intended.